students, faculty, families, board, Chancellor Halperin. It's really a great honor to be with you today and help celebrate this wonderful occasion for so many of you. This is an incredibly exciting time for you, and I think it will be interesting for you all to track among yourselves the paths your career takes, be it academia, industry, education, even law, or other directions you might go. Whatever direction you take, however, I consider it highly likely that you will, at some point along the way, face some significant adversity. And how well you do in life will have as much to do with how you manage that adversity and power your way through it as any of the other talents you bring forward into your careers. I want to give you an example of someone who faced adversity and tell you more about that personal story. I think it's illustrative in a number of ways, and at least for me raises a number of questions about the nature of what it is, the nature of what we do is. And the story I want to tell you about is about Dr. Kleiner, who you just heard about. I had learned first about Dr. Kleiner reading a fantastic book, which I would recommend to anyone interested in science, be they a scientist or a layperson. It's called The Discovery of Insulin by Michael Bliss. He's a Toronto historian who went through all of the historical antecedents to the discovery of the insulin in Toronto by Banting, Best, Collip, and MacLeod in 1922. At the beginning of the book, he goes through the background leading to the discovery of insulin and all the scientists who had contributed to it before the monumental discovery of the Toronto group. One of the individuals he wrote about briefly was Dr. Kleiner, who had done some early work on the regulation of blood glucose. And he describes Kleiner's work in his book as follows. Of all the publications before the work in Toronto, his was the most well developed. His controls had been impressive. His follow-up discussion was a beautiful piece of scientific writing. In 1919, he was closer to success than any of them, and later on made no claims at all. Bliss does not say what happened to Kleiner. He just disappeared from the scene in 1919 and was never heard of in the scientific community writ large, other than, as I'll tell you, the impact he had on this institution. Kleiner worked at Rockefeller University, where I now work, a century before. I had the good fortune of identifying a hormone. He did not, and I wondered why. And so I called Bliss, who I had encountered a few times in Toronto, and I said, well, what happened to Kleiner? And he said, I don't know. I've wondered. If you find out, give me a call. So I decided to find out. One digression, I didn't know really where to begin. I'm not a historian. I went to the Rockefeller archives. They found some materials that were interesting and told me there was something interesting here. But I thought it'd be useful to try to find his family. So I found his obituary in 1966. I looked through who his relatives were, and I found the name of his daughter, Ruth Glantz. There are not many Ruth Glantz in the phone book or on the internet. There was one in Connecticut. I called the number. They said, oh, Ruth has moved to Phoenix. I called a facility for older people in Phoenix, and Ruth answered the phone. And we had a lovely conversation because we were both interested in the same thing, and that is talking about her father. And through Ruth and her sons, Israel's grandsons, I learned much about his personal story along with other sources along the way. So this is Kleiner's story. He was raised in New Haven, went to Yale undergrad, got a Ph.D. from Yale in 1908. His Ph.D. concerned the fate of glucose injected into animals. And in 1911, after a brief teaching stint at Tulane, he moved to Rockefeller to work with one of the giants of his in physiology of the day, Samuel Meltzer. Meltzer is the person who first developed a respirator. But Kleiner went there to study the regulation of blood glucose. And there had been a major technical advance at the time. For the first time in the history of science, it became possible to measure the amount of glucose in blood. Before, it would take 30 cc's of blood, making it impossible to do meaningful animal studies, and that had now been reduced to less than a milliliter. Shortly after arriving, Kleiner did an amazing experiment. He took diabetic dogs. It had been known since 1898 in the work of Minkowski that if you remove the pancreas, dogs become diabetic. The explanation for this was not known. Some people believed that the pancreas made a hormone that regulated blood glucose, which we now know to be the case. Others believed that was not the explanation. Many, many investigators have been following up on it, but none had been able to measure blood glucose previously. Kleiner could, and he does the following experiment in 1914. He takes diabetic dogs who don't have a pancreas. In one case, he gives a bolus of blood glucose, and their blood glucose goes sky high. He now repeats that experiment, co-administering an extract of pancreas, and now the blood glucose does not go high. He presents this work at the National Academy of Science in 1914. This is for the cognoscenti, the first glucose tolerance test, as best as I can tell. And it is met with massive acclaim. There's a New York Times article in 1914, the headline of which reads, "Scientists discover the cause of diabetes, now seek cure." Meltzer, his lab head, is not happy about this. He reacts negatively, claiming that the yellow dog journalists will not tell him how to conduct his research. He directs Kleiner at the time to do a somewhat abstract set of experiments, trying to figure out why the glucose didn't leave the blood in the presence of the pancreatic extract. Kleiner pursues this for a little while, but then wants to prove that he has the pancreatic hormone that had been suggested by many since the work of Minkowski. The sine qua non at the time for identifying a pancreatic hormone was to show that it would stimulate the metabolism of blood glucose. And you could assess this at the time and still by measuring blood gases in a measurement that some of you may have heard of named an RQ. But the ability to measure the RQ, the amount of CO2 produced from nutrient, was limited to only 3 laboratories in Europe. So Kleiner goes on his great adventure to Europe to learn this method, to come home and prove that he had the diabetic hormone. He is in Europe in 1914 when Archduke Ferdinand is assassinated in Serbia. Europe explodes. He barely makes it out of Paris home, comes back to a Rockefeller that is now transformed by World War I. At the time, there was no NIH. There was no funding for research other from institutions such as Rockefeller that had an endowment. And so when he returns to Rockefeller, the research mission is altered by the fact that Rockefeller Institute, or now university, is now providing antisera to treat infectious disease to the U.S. Army. They are basically underwriting a lot of the medical treatment for about 3/5 of the great pathogens of the day. This is pre-antibiotics, and the only way to treat infectious disease at the time is by immunizing horses and then giving horse serum to patients who have been infected. There's very little place for Meltzer's research at this point, given that changed direction at the university. And in fact, in 1916, he is transferred to Yale back to teach because all of the other professors there all the medical professors have joined the war effort. He returns to Rockefeller in 1918 and is told the lab that he worked in, Meltzer's lab, is going to close. The reason it's closing is because of a separate reason altogether. Meltzer has started a pacifist organization during the war opposed to the war. It's called the Medical Brotherhood. It ultimately has more than 10,000 members. Flexner, the head of the institute, is unhappy with this new direction, feeling that Meltzer is not spending sufficient time on his research, and moreover is concerned about the political implications of having a former German scientist forming a pacifist organization. In fact, those fears are realized in 1916 when a New York Times article appears accusing Meltzer of pro-German sympathies. Because of these reasons, in 1918, Flexner decides the Meltzer lab will close and Kleiner has to find a new job. There is no place for him at the institution, despite the promise of the work that he has been conducting. Kleiner is in a panic. He has a young wife, a young daughter, he's supporting his mother-in-law, and he has no means of support, and there are no jobs at very, very few places. But in 1919, he's offered a position as the head of biochemistry at the New York Homeopathic Hospital. Before he leaves, though, he does one last experiment in 1919. And I find it very poignant that he does this experiment because by this time he knows his research career is over. But what he does in 1919 is show that an extract of pancreas, but not salivary gland, can cure diabetes in a dog. It's an incredible paper. It's one of the most beautiful papers I've ever written. And he writes this paper, he submits this paper the last month he's at the Institute and sends the paper to Flexner. He moves now to New York Homeopathic Hospital, the institution you now work at, and begins working in biochemistry. In 1921, he actually becomes dean in the midst of a major financial crisis that is alleviated only when he raises substantial amounts of funds from the Waterman Pen Company. He precedes his chair, he's an educator, no active research at the time, and in 1922 he reads an article in the paper about the discovery of insulin. Now imagine, you'd had the opportunity to discover the most important hormone ever discovered. It's been taken away from you at the last minute, and now you're reading in 1922 that someone else had discovered it. If he was crushed, he never revealed it to anyone, including his family. He simply wrote a letter to Flexner reminding him that this was the work he had been pursuing and resent him the paper he had previously sent him in 1919. He continues his career here at the New York Homeopathic Hospital, now New York Medical College, for the rest of his life. In 1925, he steps down as dean to pursue a career in research, to resume his career in research and teaching. He spends his summers at the Cold Spring Harbor Laboratory doing research, spends the rest of his time here as chair of biochemistry, working diligently to try to remove homeopathy from the curriculum, which he succeeds in doing in 1935. He wins several Teacher of the Year awards, writes a very influential and important textbook, Human Biochemistry, for which he receives a great deal of recognition as having written one of the most important textbook of his day. In 1954, he receives the only recognition he will ever receive, the Van Slyke Award. And on that occasion, many people write letters to him saying things like, Banting, Best, Collett, McLeod may have identified insulin, but your studies clearly led the way. And that included many of his great detractors. He simply said, my place in this story is of little consequence and shall be told another time. He never did actually tell his story. He retired in the late 1950s, passed away in 1966, a beloved husband, father, grandfather, and by all accounts, a beloved teacher here. So I often think to myself, I was working on this hormone, how might I have reacted if things had gone differently than they did? Would I have had the fortitude to find a new path in life and impact people in the world in a different way than I originally aspired to, but one that's no less valuable as a family man, a teacher, an administrator, and sometime researcher? I don't know, but I think in some ways that would have been the greatest challenge of all. Booker T. Washington said, success is to be measured not so much by the position that one has reached in life, but by the obstacle that one has overcome. And I think it's all of our abilities to overcome these obstacles that will define us. Thank you for giving me the opportunity to be here today, and I wish you all the great luck in the next phase of your career.